Okay, so on here, we had for the first 6 of these, it was all kind of the same idea. We were finding our radius and circumference and then rounding to the nearest hundredth. So in each case, and we have our equation for circumference. Circumference equals pi times diameter. Or again, we could have also used circumference equals 2 pi r. But since we're finding both circumference and diameter, I'm going to go ahead and use that first formula and find my diameter. And once I know my diameter, then we can go ahead and just divide that in half. So on these problems, in order to get my diameter by itself, really all I'm going to have to do, take that formula. If I divide off pi, so I'm doing my circumference over pi, it's going to give me my diameter. That's what I'm going to have to do each and every time here, since I was given the circumference. They asked us to round to the nearest hundredth, so we do want to plug into our calculator. Now, there are a couple options for plugging into the calculator. It didn't say what to use for pi, so there is a pi button on your calculator that will give you the most exact answer possible when rounding. But if you use 3.14 or 22/7, that'd be fine. Just know that your answers might be slightly different than what I have here, since I'm going to use the pi button on the calculator. And again, if you're using the calculator that's up there on the screen, the pi button on this calculator is over here to the left. So again, if I hit it, you'll see it comes up with 3.141592654. So it uses a lot more decimals than just the 3.14. All right. So on the first one, again, all we're actually doing is doing 40 divided by pi, and that's going to give us our diameter. So what's our diameter on this one? Well, 40 divided by pi is, again, you gotta make sure you hit equals 12.73. If that's our diameter, then our radius is going to be half of that. So divide that in half, and we get 6.37 if we round it up. And since we had units involved, since these are measurements, we should also include those units here. So these were both in inches. All right, we're going to show the same thing again for number 2. So again, to get the diameter, we're doing the circumference that was given to us, the 256 divided by pi. Again, I'm just typing that into my calculator. 256 divided by pi equals, and it gives me 81.4, and that's going to round up 49. Now, for the next one, again, oh, sorry, we got to do the radius. So divide that in half, divide that by 2, and we get our radius is 40.74. Both of these are in feet, so I should include those units. Feet and feet. If your problem has units, always make sure you include those. For the next, well, this chapter will probably have quite a few that involve units like that. And then also when we get into our 3D solids, we'll have a lot that include units on them. So again, just make sure you include units if they're given. All right, so I'm just going to go ahead and list out the rest of these answers because it's the same thing each time. Taking the number, divided by pi, you got your diameter, then divide in half to get our radius. So the rest of these answers are as follows. Number 3, we have diameter on this one is 4.79 meters. The radius is 2.49 meters. For number 4, it's this is our diameter, is 2.86 centimeters. Our radius is 1.43 centimeters. For number 5, we had the diameter is 25.31 yards. The radius, 12.65 yards. On number 6, the diameter is 64.99. The radius, oh, and this was in meters. The radius is 32.49 meters. All right, down on the bottom part, it was a little bit different. Again, we still had to use our formulas, but we're back to using the two main formulas. So either, let me erase this extra bit that we did here. So either those original two formulas that we have of circumference equals pi times diameter, or circumference equals 2 pi r. On each one of these shapes, though, you were given parts that weren't the diameter and weren't the radius, and you had to find them. So you're taking ideas from the last section in chapter 8. You had to apply them here in order to find a missing piece, and then you could plug it into your formula. So it did say find the exact. So anytime they use that word exact, that means that we want to leave our answers in terms of pi. So I'm going to write that here. Leave answers in terms of pi. Now, it also means that if we get a radical, we might also have to leave the radical as well. So these answers might look a little crazy, but that's okay. Number 7. We have our two sides of a right triangle. How do we find the missing side of a right triangle? If you're given two sides, how do we find the third side? Pythagorean theorem. All right, so on here, I have 6, 8. Wait a minute, those numbers might look familiar. I could use Pythagorean theorem on this one, which is c squared equals a squared plus b squared. But these two numbers, this is our 3, 4, 5 multiplied by 2. So 6 is 3 times 2. 8 was 4 times 2. So this missing side here have to be 10, because that's 5 times 2. So again, this is where, if you know those triples, I said that we're going to see a lot of problems in future sections where we're able to use those triples to find missing pieces faster. This is an example of that. So we have 10 is our diameter. Once we know that 10 is our diameter, we're just plugging in. So C equals pi times 10. Well, actually, that's our answer. So we're just going to flip that around. 10 pi centimeters. Don't have to multiply anything out. That's it. Now, if you had plugged this in the calculator, so if you did this and found a decimal, just so you know what it was as a decimal, it would have been roughly 31.4. All right, but again, that's where we should have stopped with our answer, is the 10 pi. All right, number 8, we have this one side given to us, but they tell us that this is 9, and they have this marked congruent to the other side. So this is also 9. Is this diagram drawn to scale? No, because if this is 9 and this is also congruent to that, that means this should be what type of triangle? This should be our isosceles right triangle, also known as our 45, 45, 90. Again, definitely not drawn to scale, but if these are both 9, what's the diameter going to be? No, 9 square root of 2. All right. Again, that's using our properties. Let me draw my triangle over here, right? For 45, 45, 90. Our two legs are going to be the same. The hypotenuse is our leg times square root of 2. So we have that side. Now that we have that side, we can plug it into our equation. Well, again, we're just doing diameter times pi. So we have 9 radical 2 times pi. We're leaving it in terms of pi, so that's it. That's our answer. So our answer is 9 radical 2 pi inches. We don't have to do anything else to it. Number 9, they gave us two sides of a rectangle. Well, this other side would then also be 3. So we have, let's see, 3 and 7. Well, this one is not going to be one of triples, right? So we're going to have to actually plug into Pythagorean theorem this time. We don't know the diagonal that's going through the middle, which is going to be our hypotenuse. I'm going to call that c squared for right now. The other two we're plugging in for a and b. So we get 3 squared is 9, 7 squared is 49. Together, 9 plus 49 is 58. So we get the square root of 58. Are there any perfect squares in 58? No. So that's actually just going to stay 58, square root of 58. So this length here is square root of 58. That's our diameter. So when we do our circumference formula, again, it's just our diameter times pi. So that's square root of 58 pi. This was in millimeters, so it's stay in millimeters, and that's our answer. Now, proper way of leaving an answer. So I've done this twice now on 8 and 9. We saw, especially on 8, we had a whole number, then we had a radical, then we had pi. That is the proper order to leave our answers when dealing with both radicals and terms of pi. So you should always do a whole number first if you have one, then your radical, and then pi. All right, on number 9, we didn't have a whole number, but we still had a radical and then pi. So that, again, that's the proper order. On number 10, we have a square. All right, they showed we had all these are right angles, and they told us the length of this was 11. Now, that 11, what is that acting as actually for the circle? That's the same length, right? So if I drew in a line here, it'd be parallel to it. So this too is 11 yards. That's our diameter. So they actually gave us our diameter on this one. So we have 11 times pi. And again, that's our answer, 11 pi yards. Number 11, these two, we have a 5, we have a 12. Wait a minute, that's one of our triples. What's the missing side? So this whole side is 13. So we already know we have 13 centimeters as our diameter. And I'll write that off to the side. That's a triple, 5, 12, 13. Our circumference then is 13 times pi. And again, this was in centimeters. And there's no other work to be done. On 12, all right, they gave us the two sides are square root of 2. Well, if those are square root of 2, this side is normally the one that has the square root, right? So we still have to multiply by square root of 2. What will this side be? So what's square root of 2 times square root of 2? 4. So that side's 4. So we now have our diameter. So our circumference here is 4 pi, and those are in centimeters. And that's our answer. So there's not actually a whole lot of other work to do there. The biggest part of the assignment I gave you yesterday was still using properties from chapter 8, right? Almost every single one of those, you had to use a property that was from that last test, and then you plugged into the equation, but since they wanted it as an exact value, there's nothing else to do. You just left it like that. So that was our answer. All right, any questions there? All right, let's go to the next page. So let me clear this off. All right. So most of these are similar to what we did yesterday. There are a few on here that I want to do with you before I turn you loose on the assignment. So on the top part, again, we're just naming the different pieces. So naming the circle, naming the radius, naming the chord, naming the diameter. That part you should be fine with. On 5, name a radius not drawn as part of the diameter. So again, it's just naming a figure, making sure it's not part of the diameter. That, again, you should try on your own. There are a couple that I did want to look at. So I wanted to look at 8 and 9 with you on this page. Let me scoot this up a little bit. Oops. Not too far. Wait a minute. Hold on, was I on the wrong page before? This was the page one. I wanted skills practice 89. All right. Yeah, I'll give them for you after we do this. All right. Okay, so on 8 and 9, we have diameters of circle F and circle G. So there's two separate circles here. So the diameter of F is 5 and 6 units respectively. So 5 for F. So this distance all the way from here to here is 5. And then from B to C is 6. And they want us to find the missing measures. So, well, if that entire length is 5, what's the radius of that smaller circle for circle F? What's the radius of circle F? So if the diameter is 5, the radius has to be what compared to the diameter? Half. So if this is 5, that's going to be 2.5. So this piece here from F to G has to be 2.5. And then also from A to F, this piece would also have to be 2.5. And then for the bigger circle, what's the radius going to be? 3. So then from B to G, it's going to be 3. So the first part of this is making sure you identify all the parts that are needed. But then it's just a matter of segment addition after that. So now we're going all the way back to chapter 1, segment addition. We have to find the length of BF. Well, BF is the difference between this entire length of BG and the length of FG. But I have both of those parts. BG is 3. FG is 2.5. So I have 3 minus 2.5, which gives me a length of 0.5. That's going to be the length of BF. AB. Now, AB is this piece. Well, I know that this little piece now is 0.5. So now I'm taking AF, which was 2.5, subtracting off the 0.5, and the answer is 2. So the length of AB is 2. Any questions there? All right. The other questions at the bottom are pretty much the exact same as what we had done yesterday. Let me see if there's anything else I'm doing on the homework that's different. That's kind of the same. That's the same. That's the same. Yeah, no. Everything else is like what we did yesterday. Any questions before I let you guys get started on this? So you have some time left in class because we don't get out of here for a little while. But and that's it. So just make sure you get those 2 pages done. So you're doing pages 7 and 8 today. And I will post this online.